Hello everyone, and in this video I thought I'd look at switch gears and have a look at a mechanics question. And this one is a pulleys question. Okay, now it says two blocks A and B of masses 2m and 3m respectively attached to the ends of a light string. A is initially held at rest on a fixed rough plane. The plane is inclined at angle alpha to the horizontal, where tan alpha is equal to 5/12. The string passes over a small smooth pulley P fixed at the top of the plane. The part of the string AP is parallel to the line of greatest slope of the plane, and the block B hangs freely below P as shown in figure 1. The coefficient of friction between A and the plane is 2/3. The blocks are released from rest with the string taut and A moves up the plane. The tension in the string immediately after the blocks are released is T. The blocks are modelled as particles and the string is modelled as being inextensible. Show that T is equal to 12 mg/5, 8 marks. Okay, right. Step 1 is we need to get a sketch representing the situation. Okay, so we have 2m here. And we have our string there. Okay, and then we have this block here, which is 3m. So we have A there, 2m, and we have B here. Okay, what have we got? We've got the weight of this. So this is 3mg pulling down there. We have the weight of this one, which is 2mg. We have the angle here, alpha. And the important thing to remember is that this angle here is also alpha. Okay, so that is also alpha. Perfect. Now, we have the normal reaction from the block there, which I'm going to call R. We have the tension in the string there, and there, and there, and there. And it's a rough plane, and we're told that it's moving up the plane, and therefore the frictional force is going to be opposing the direction of motion. So the frictional force is going to be acting down the plane as block A moves up the plane and block B moves down. Okay, there we go. Now, what else is useful? It's always useful to do the information here about our little triangle. They tell us that tan alpha, tan being opposite over adjacent, is 5/12. This is a Pythagorean triple, so that means that the hypotenuse is 13, because 5, 12, 13 is a Pythagorean triple. So that means that we can now use this little triangle to work out our cos. In fact, let's write that down. Cos of alpha is going to be adjacent over hypotenuse, so 12/13, and sine of alpha is going to be opposite over hypotenuse, so it's going to be 5/13. So there's all the elements that we need ready to begin the question now. So first of all, we need to find, well, in questions of this type, this is an A2 question because we've got friction as well. Step 1 is I would always find out what R is by resolving perpendicular to the plane for A. So for particle A, we're going to resolve perpendicular to the plane. And let's see what that gives us. That's going to give us that R is equal to mg cos alpha, because this side is the adjacent, so cos alpha for that side. So it's going to be 2mg cos alpha, and we know that cos alpha is 12/13. So it's going to be 2mg times by 12/13, which is going to be 24mg/13. So we've got an expression there for R, which is always going to be super useful. Now we're going to, because we know that our frictional force, let's find that as well now, we may as well. F is mu R, because we're going to have the maximum value of friction as it's going up the plane. We're told that the coefficient of friction between the block and the plane is 2/3. So we have 2/3 times by our 24/13 mg. So now we're getting an expression for F as well. So let's have a look at that. So we've got 2/3 multiplied by our 24/13, and that gives us 16/13 mg. So 16/13 mg is our F. Okay, there we go. So now it's time to write down two separate equations. It's time to write down an equation for A and then a separate equation for B. Now, in a Pulley question, we have to deal with A and B separately because they're both going in different directions. So that's a really important thing to remember in a Pulley question, that we must deal with the two blocks separately. So let's have a look at, first of all, resolving up the slope, and this is for particle A. So I'm going to write down Newton's second law, F is equal to ma, and let's see what we've got for this particle. Well, it's being pulled up the slope by the tension. So we've got tension, and it's being resisted by the component of its own weight that's acting down the slope, which is 2 mg times by sine alpha. So that's this component. So we've got tension minus 2 mg sine alpha. And we've also got the frictional force is opposing it as well. So minus the frictional force is equal to its mass, which is 2m, times by the acceleration, which we do not know. Okay, that is fine. So let's see what we can put in there. We know that sine alpha is equal to 5/13, and we know that F is 16/13 mg. So let's put those expressions in as well. So tension minus 2 mg times by sine alpha, which is 5/13, minus F, which we know is 16/13 mg, is equal to 2ma. Okay, that's looking good. So I think we can basically like combine some of these two terms here now. So we're going to have that times that is going to give us 10/13. So we've got 10/13. Oops, 10/13. There we go. And we're going to add to that 16/13. So that's going to give us minus 26/13. Okay, so that's going to be minus 26/13 mg. T minus 26/13 mg equals 2ma. And then our 26/13 is going to be 2. So we've got T minus 2 mg is equal to 2ma. Okay, let's park that result there and just keep that there for a moment. We've now got our equation from resolving up the plane. Now we turn our attention to particle B, and we're going to do a similar thing for particle B. We're going to resolve going down the plane. So let's now turn our attention to B, resolve going downwards rather. So for B, we're going to resolve going down, and this is for B. So we write down F equals ma, Newton's second law. This time the weight is what's pulling it down. So we have 3 mg minus the tension is equal to the mass, which is 3m times the acceleration. And we've got our equation there for the second equation. Okay, now we've got two equations now. Okay, let's have a look at them. There they both are. Both involving T and A. Now we're being required to show here that T is equal to 12 mg/5. So actually, I think I could just rearrange this equation to make A the subject, or indeed this equation, and sub one into the other. I think that would be perfectly fine. So I might actually, it doesn't matter which one, I'm going to rearrange this one to make A the subject, and then I'm going to sub it into there. An alternative version of this is you could add together the two equations in order to eliminate the tension. So I could do equation 1 add equation 2, which would cause T to cancel. And then I would get an expression which would give me my A. And then, do you know what? Actually, that might be easier. I'm going to do that actually. I think that would be easier. I'm going to say equation 1 add equation 2. If I add those two equations together, so let me write that down. So I'm going to have T minus 2 mg is equal to 2ma. So that's my equation 1. And I'm going to add to it the second equation, which is 3 mg minus T is equal to 3ma. Yeah, I just decided to do it this way rather than rearrange and make A the subject, just because I think it drops out quite nicely here. So I'm going to add these two equations together. So the t's are going to cancel, and 3 take away 2 is just going to give me mg. And then I'm going to have 3 add 2 is going to be 5 ma. My m's will cancel, and so my acceleration turns out to be 1/5 of g, which is super nice. So now I can go back to either of my equations and work out what the tension is. Let's use this one, T minus 2mg equals 2ma. So T minus 2mg equals 2ma. And we now know that the acceleration is 1/5 g. So we have T minus 2mg is equal to 2ma, and a is 1/5 g. So that's 2mg over 5 is equal to T minus 2mg. We're now going to add the 2mg across to the other side. So T is equal to 2mg over 5 add 2mg. This 2mg can be pictured as being 10 mg over 5. So we have 2mg over 5 add 10 mg over 5, which gives us 12 mg over 5 as required. There we go. And that's quite a nice 8 marks. And the thing I would say about pulleys is they are very, very sort of procedural, very sequential. It's always the same steps that you always follow. You always get a nice diagram, super important. In this, because this is a year 13 one, we needed to find out, resolve perpendicular to the plane to work out the normal reaction. Again, you pretty much always have to do that. That enabled us to find our friction. And then we write down an equation of motion for A, we write down an equation of motion for B, and we solve those two simultaneously to find out what our A and our T are. And it's always the same kind of procedure with pulley questions like that. Okay, so that's our 8 marks done. I thought that was quite nice for 8 marks. Let's see what's next. After B reaches the ground, A continues to move up the plane until it comes to rest before reaching P. Determine whether or not A will remain at rest. So let's just have a little visualization here of what's happening. So what happens is B reaches the ground, the string goes slack, and A continues to slide up the slope before it comes to rest. Okay, so there it is. The string's gone slack, A's moved up the slope, and it's come to rest there. Now the question is it just going to be momentarily at rest, or is it going to start sliding back down the slope? So in order to work this out, let's think about what's going to happen. Let's think about what forces A is subject to. So A still has gravity there, which is 2mg. Okay, and there is our alpha. So just the same, its component of its weight is acting down the plane. Now, because A is on the point of sliding back down the slope, the frictional force has now changed direction. So our frictional force is now acting that way. Okay. So those are the only two forces that A is subject to in that horizontal direction. Its weight pulling it down the slope and the frictional force trying to stop it. So let's resolve now. Let's resolve parallel to the plane, and let's see what we've got. So we've got the component going down the slope, which is 2mg sine alpha. And you may remember that we said that our sine alpha was 5 over 13. So we have 2mg times by 5 over 13, which is 10 mg over 13 acting down the slope. Let's see what's the force acting up the slope. Well, our frictional force, you may remember, was 16 over 13 mg. 16 over 13 mg is acting up the slope. Now, this 10 mg over 13 is less than 16 over 13 mg. In other words, the component of the force that's pulling it down the slope is less than the frictional force that's holding it in place. So therefore it will not move. Okay, so therefore A will remain at rest. Okay, and that's what we need to get the marks. Okay, I think that demonstrating that we understand that we've considered the two forces that the block is subject to, and that we can conclude that it's not going to move, because the force pulling it down the plane is less than the force, a friction that's holding it in place. And then finally, for this question, it says suggest two refinements to the model that would make it more realistic. And there's so many things we could say there. We could take into account friction at the pulley. That would be one thing, would make it more realistic. We could take into account the fact that the string itself might have some weight, which would cause the tension not to be the same in all parts of the string. And instead of modeling the blocks as particles, we could consider the physical dimensions of the blocks. So we could say we could model the friction, having friction at the pulley. We could say that the string might not be inextensible. We could say that the string might have weight, mass rather, and we can say that A and B might not be modeled as particles. And any one of those would be perfectly acceptable. And if we bring across our solutions, you can see some of those modeling assumptions are written there. Perfect. Well, I hope you found that video helpful, and I will see you in the next video.